Hey everyone, today we're going to be talking about matter, so that's fun. So let's start by defining chemistry. Chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. Composition is what something is made of, structure is how something is put together, and properties are how something behaves. So matter is defined by two properties, mass and volume. So matter is anything that has mass and volume. So, for example, if you're taking notes with a pen right now, that would be matter, because it has mass and volume. We have mass and volume, so we're matter. The air has mass and volume, so that's also matter. Some things that aren't matter would be space, because that's empty, or light, sound, and heat, because they're forms of energy. So mass is the amount of matter in an object, and volume is the amount of space an object occupies. So let's look at the building blocks of matter. An atom is a small unit of matter that retains its identity. So some examples would be hydrogen, copper, or neon, and they're fundamental particles. Elements are types of atoms. Oh, my bad. Molecules are two or more atoms that are chemically combined. And compounds are types of molecules. So let's look at the properties of matter. So there's qualitative and quantitative properties. So a qualitative property is a characteristic that can be observed without measurement. So an example of this would be color, whereas a quantitative property is a characteristic that can only be observed by measurement. So for example, we have height and we have mass. So let's also look at some other properties, such as intensive versus extensive properties. So intensive properties don't really depend on the amount of substance present. For example, there's color, right? Having like more of something doesn't change its color usually. And density, right? Because it's a ratio of mass to volume. So even if you have more of the substance, the ratio stays the same. Extensive properties do depend on the amount of substance present. So some examples of this would be mass, because if you have more something, you typically have more matter, and so more mass, and length. There are also physical versus chemical properties. So a physical property can be observed without a change in the substance's identity. So for example, ice is cold. Well, you don't need to change the identity of substance in order to observe that. However, a chemical property can only be observed by changing the identity of the substance. So for example, when we say iron rusts, we only know that through changing the identity of the substance from regular pure iron to iron oxide. Looking at the physical and chemical properties, we can also connect that to physical and chemical changes. So they depend on whether or not the identity has changed. So a physical change is one in which the identity is not changed, whereas a chemical change does affect the identity of the substance. So ripping paper does not change the identity of the substance, therefore it is a physical change. Burning paper, however, does change the identity of the substance, therefore it is a chemical change. So states of matter can be defined through volume and shape. So solids are things that have definite shape and volume. Liquids have an indefinite shape, but a definite volume. And gas has an indefinite shape and volume. So now let's take a look at chemical reactions. They have two parts, reactants and products. So reactants are the things that react, and products are the things that are made. So they can produce a change in energy, right? So in an endothermic reaction, energy is absorbed, so it would feel colder because it takes energy from the environment and absorbs that. Whereas in an exothermic reaction, energy is released and therefore it would feel warmer. The law of conservation of matter states that matter can neither be created or destroyed. It was discovered by Antoine Lavoisier, who's considered the father of modern chemistry. Sorry if I butchered that name. So, the total mass of reactants in a reaction chamber would equal the total mass of the products according to this law. So you can use that to do problems where they give you let's say like 2 of the reactants and 1 of the products, and they want you to find the mass of the other product, you can find that because you know the total mass of the reactants is going to equal the total mass of the products. Let's look at classifying matter now to finish off the video. So matter can be classified into 2 categories. So there's pure substances, and that's matter that has a fixed composition. So all samples have the same characteristic properties. So elements are pure substances because they are only made of one type of atom, gold, iron, or hydrogen as examples. And compounds are also pure substances because they are made of 2 or more atoms in definite ratios. So like water would be 1, salt would be 1, and carbon dioxide. These are all examples of compounds and pure substances. However, mixtures are physical combinations of 2 or more pure substances, so that means the identity does not change. So one example would be salt and water. That's a mixture, that's salt water, and the identity does not change in this mixture, or in any mixture, because they are physical combinations. Now, there are 2 types of mixtures. There are homogeneous mixtures, which are also known as solutions, and they are a mixture with a consistent composition throughout. So an example would be an alloy, because they have a consistent composition throughout the whole thing. You can't see any phases. There would also be like gaseous solutions like air, because they're distinct. There's no distinct phases. They all have a consistent composition. There are also heterogeneous mixtures, I can't really pronounce this, I'm sorry, with distinct phases and parts to it. So some examples would be oil and vinegar, because you can see them and there are like distinct phases and parts to it. It's not really consistent throughout. Tile marbling too, if you have like tile marbling with like some sort of like swirly patterns, those would be heterogeneous mixtures. So yeah, you can see distinct phases. So that's our quick intro to matter, and we hope you enjoyed that.